Let's see another linked list problem from LeetCode, and this is the hard problem as per LeetCode. So let's try to understand, and then we'll see two different approach to solve this problem. So in the problem, it's saying there are multiple sorted list, and this is the linked list. So multiple sorted linked list are given here, and we need to merge this to one, and then the final output will be the one linked list, that's a merged linked list, and that's also in a sorted order. So 1 4 5, if you see, the 1 is here, the 1, all 1 came here, and then 2. So this is the sorted. So yeah, problem description is very easy here. How to solve this one? So there are two different approach. There can be multiple approaches, but I'll just show you two best approach we can solve this. One is using the MinHeap data structure. If you use the MinHeap data structure, then it will be very easy, and it doesn't care like if it is sorted or not sorted. So in any case, that heap data structure will work here. So for the heap data structure, I will not explain a lot, but you can go here and see this video. So if you just search in YouTube, then this is LeetCode, and you can come to the playlist, you can search for the heap, and then there is a LeetCode hand of straits problem. So this problem also use the MinHeap technique. So you can go here and just understand the MinHeap, and once you have good understanding on the MinHeap, come back and you can see the code here. But in a MinHeap data structure, I'll just put the code and I'll show you how it works. But in MinHeap data structure, what we do, we iterate through the list, and we'll get one by one item and just put that in a MinHeap. So when we put all the item in a MinHeap, that insertion is usually the n log n, but when we pop the item from there, that's on the constant time. So put all the item in a MinHeap and pop item one by one. So when we pop the item, you will get that's in a sorted order. So you'll get from the MinHeap, the first item will be 1, again 1, and then again 2. So in that way you can form the linked list. So that is the one approach. So one approach, the first approach is you put all the items in a MinHeap and get the item one by one from the MinHeap, and that is that's already sorted. And then we can form one linked list, we can return that, and that will be the merged list. So that is the first approach. And the second approach we are going to look, what we do here, we'll write a function to merge two lists. So if I give this two input, this two input to a function, that function will easily merge this list and then return the new one. And again I will check another one here, and I'll check if there is another one also. So every time I'll take the two list from this big list, I will take the two list and pass this to a function, and that function will return the merged list. Again I will take the another two if there is, and I will merge that, and then again the merged one, this merged and this merged, I collect and put that in another list. So in that way the bigger list will be minimized. Like let's say in this list there are 3 items, and when I take these 2 items, I merge, it becomes 1, and again I will take 2 items, but there is only 1, and for this also I merged will be 2 6. So now there will be 2 items, this is already merged and this is already merged. Again I will call for this 2, and then that will also get merged finally. So the two approach we'll see, but in the second approach the condition should be, the list should be already sorted. This should be also sorted, this should be also sorted, this should be also sorted. But for in the first approach we do not care if it is sorted or unsorted, it works in either case. So let's see the solution for that. Code looks a little bit bigger, but it's a very simple code. So if you go back and see this video you will get the idea about how to create MinHeap. So this is the function till here. This is about the MinHeap. So this is the function. So merge list, and I have commented this portion. We'll see one by one. And first let me comment approach 2 here. I will comment this logic. This is approach 2, and then I will uncomment the approach 1 logic here, and we'll see how it works. Let's say a little bit about this MinHeap. So the list node here, we have the list node here. So in this list node, this is the array of list node. That means one head. Like let's say if you iterate this, there will be 3 heads here. One head contain 145, another head contain 135, another head contain 26. So for the list node, I created the MinHeap. So I took this list node and init heap, and this is the len swap function just we use for the MinHeap. The condition is required here, the MinHeap, and then we need this function. So till here we have already created the MinHeap, so we can get this idea from that, the other videos from here. And then that's the one prerequisite, and then at least I can assume that you are good on this MinHeap things. So this is our main function. Here I'm going to initialize our MinHeap, so this 2 line, and then see here, this is the list, and I'm getting the item one by one. So if I iterate this is the array of the head node. So this is 145. So this node, I will get the node for this, again I will get the node for this, and I will get the node for this. Then for the let's assume I got the first node. So for the first node, I'm iterating the first node, for loop, there is a for loop, and when I get the item, I just push that in a MinHeap. I push that node in a MinHeap, and then check for the next node. So I will iterate until this one is not nil. So it will iterate 145, and we put the 145 in a MinHeap, and then we'll get another one 134, and then again the inner for loop, take item one by one, and then just we put that in a MinHeap. In the similar way, we'll get the another one, and again that we put that in a MinHeap. So till here we put all the items in a MinHeap, and the next thing is we want to pop the item one by one. So I created a new head here, new head, this is the new node. For the new head, this is the new node, this is the same, pointing to the same, and I'm checking here for the heap len not equal to 0. So I'm iterating as long as there is a item in a MinHeap, we'll take the item one by one. So this is the way I'm taking the item from the MinHeap, and then in this new node, new node next I put that item, and then I move the new node pointer to the next, and in this way I'll get one by one all the item and just keep linking to the new node, and at the end I can return new node next, because here new head so the new head has a item, and this is the empty, and the next item will be new node. Next item will be our actual node. So that's why I'm returning new node head here. So this is a very simple logic. Just submit this, it will run. I have already tried that. Okay, so come back to the approach 2. Let's comment this logic. And uncomment approach 2 logic. Okay, so before coming to the approach 2 logic, let's see one additional functions. We need to use this additional function in a approach 2. So in this function we are passing toList, any toList, and then we are merging this. The toList, I created a new list here, and there's a new head, so both pointing to the same empty list. And then there's a loop. I'm checking L1 not nil, L2 not nil. So if there is a item, as long as there is item in a L1 and L2 both, I will check like any this, like let's say this 2 item comes here, then I will check L1 item, L1.val less than L2 val. Then in a new list, next I can add the L1, otherwise I can add the L2, but in this case 1 less than 1 no. Then I will check, then again will this comes in a else portion, and in a else portion we can put that new list L2 item, L2. So this is the way we can iterate the both L1 and L2, and we can merge this two list to one. And at there is another if condition here, because at the end maybe like let's say there is example 2 list come like this and another one like this. There are 3 items, but this for loop will iterate only for till 2 item, but still there is one pending. So we'll check L1 not nil. The L2 becomes nil already, but L1 not nil because there is some item left here. If L1 not nil, then we can put that item here. We can just link that node to the new list next, and we can return at the end here, we can return new list head next. So this is the code to merge two lists. So only one thing in a main logic we have to do is we have to get the 2 items and pass here and get back the merged one. Again I pass another 2, get the merged one. So we need to maintain that logic here. So now we can come here and we can check list is greater than 1. So in the original S there are 3 items in the list, 3 head, so that's of course greater than 1. And then we create the new list variable here, so we'll utilize this. But see the second for loop. In a second for loop we are getting the item from the list. We are checking there is an item in a list, and the first time the L1 in the first head is this one. So L1 is list I, so I will be 0. So L1. We'll check for the L2. So for the L2 we'll check like I plus 1 less than length of list or not, and I is 0 in the beginning, and I 0 plus 1 is 1, and 1 less than length because length is 3. So in this case we can get the L2 list I plus 1, these 2 items. And then here we call the function merge to sorted list, and we passed this L1 and L2, and it returns the merged item. It runs the merged item, and then what we did, we have created the new list here. The new list contains the merged list item, so the new list has only 1 item now. And again this time I will be incremented by 2, so I value will be it was a 0, so now I plus 0 plus 2, 2, so 2. so it points to this place. And then we'll get the L1. So L1 is list I, so I is 2, so 0 1 2, so this item we get in a L1. L2 we do not get anything for the L2 because I plus 1 there is nothing here, so we'll not get here. So this is the L2 is the nil. Again we'll pass two things, this 2 6 and the nil, and we'll get the merged one, merge list. So now new list has two items, one is this merged and the final one, this two item. New list has this two item. Okay, this is done, and as soon as the for loop is over, we'll come and we'll update this list with the new list. So initially new list has the three items, this time new list has only two items. This list has two items, so we updated the original list itself. Then we'll check that again, this two list greater than 1 is, because there are two items in this list, so greater than 1. Again we'll come here, new list, and we'll get the two items, L1 and the L2, and the two items will merge, and the new list has the merged one, final one item, and we put the one item to the list, and we'll check list greater than 1, no, because there is just only one item here. Then finally we'll come here and we'll return list 0. So let's submit this also. Okay, so we have seen these two approach. Let's see the Java solution also. For the Java solution, I have added the logic for the second approach. For the first approach, you can design also, because if you go here and see that logic, you will see the Java solution for the MinHeap also. You can utilize that MinHeap, and again you can implement that logic by yourself. But let's see the second approach here. For the second approach, again I created a function for merging two lists in the similar way. This will merge two lists, and if you come back and we'll see here the list length greater than 1. Then we created a new list here, and there's a for loop that will increment by 2. I'll get the L1 and L2, and then merge this, put that in a new list. This for loop keep going on, merging the list, and then we'll get the final new list. We put all the new list to the original list, we update that, and then finally we can return the list 0. Yeah, so that's all for today. Thank you.